Hi, I'm Anna from Cisco's TME team. Today I'm going to show you how you can migrate a live network from VPLS to EVPN without losing traffic. You didn't see that coming, did you? I meant the traffic. He's fine. So let's take a quick refresher on how VPLS and EVPN work. This is our sample VPLS network. P1, P2 and P3 are VPLS neighbors peering over an MPLS cloud. The VPLS control plane between them can use either LDP or BGP to exchange control messages. Okay, action time. P1 receives a packet from the switch on its connected link called AC or attachment circuit in VPLS talk. Immediately it adds the source MAC on the packet, say MAC1, to its MAC table as reachable via link 1. And let's say it hasn't learnt the DMAC yet, so it floods the packet out to all of its VPLS neighbors. P2 and P3 receive this packet and populate their MAC tables with the new info that they've just learned. That is, if I ever want to reach MAC1, I need to go to P1. And then since they too don't know about the destination MAC, let's say they flood the packet out to their access nodes. So as we've seen, VPLS is a flood and learn model where the MAC table is populated with MAC addresses and how to reach them only after the Ps receive the actual packet. Next, let's see how EVPN networks operate. P1, P2 and P3 are EVPN peers over the MPLS cloud. To exchange EVPN control messages, we have an internal multi-protocol BGP relationship between them. So same case, let's say P1 receives a packet from the switch on its AC called EVI or Ethernet Virtual Identifier in EVPN talk. P1 immediately learns the source MAC address on the packet and adds it to the MAC table as reachable via EVI1. And at the same time, it sends out BGP messages to all its EVPN peers saying, I've learned a new MAC, here it is. And the MAC address info goes out in a route type 2 message over the control plane to P2 and P3, and they add this info to their MAC tables. Note that the actual data packet that P1 received from the switch has not yet been transmitted out to P2 or P3 like it was in the case of VPLS. P2 and P3 learn about the new MAC and how to reach it just from the control updates that P1 sent as soon as it learned about MAC1. Okay, so what are the similarities and differences between VPLS and EVPN? In both cases on the access side, MAC addresses are learnt only when the switch sends the router a packet. This is called data plane learning. What's different is the way this MAC info is being shared with peers. In case of VPLS, the MAC info was learnt on the peers only when they received the flooded data packet. If for any reason they did not actually receive the packet, they would have no knowledge of that MAC address. In case of EVPN, the MAC info was learnt by the peers because of an update message from BGP EVPN saying, hey, here's a new MAC I just came across. If you want to reach this MAC, use me. The actual packet itself was not sent to either peer. This is called control plane learning. If we understand this, migrating from VPLS to EVPN should be as easy as EVI. That's right, you just heard an EVPN pun. Next, let's see what these steps look like in theory. These three Ps are just VPLS neighbors at this time. Let's migrate from VPLS to EVPN between P1 and P2. Like we just saw, the behavior is exactly the same for VPLS and EVPN towards the switch or the access side, but towards the core, to the other Ps, EVPN needs a BGP signaled control plane to send route updates. So first, let's establish this control plane by bringing up BGP peering for EVPN family between P1 and P2. Next, now that the control plane is up, we can focus on the access side configuration, that is EVPN specific configs like EVI and if we want to advertise MACs or not and so on. Okay, let's do this one at a time. So we configure EVPN on P1 first. The third and the final step, configure EVPN on P2 the same way we did on P1 just now. This is when the magic starts to happen. When we finish configuring the access for EVPN on P2, since our BGP control plane is ready to go from step 1, EVPN control messages are exchanged between P1 and P2 and the data plane gets set up. As soon as the EVPN session comes up, the VPLS pseudowire goes down automatically and traffic switches over from VPLS data plane to the EVPN data plane. We don't have to remove configuration to pull down the VPLS pseudowire. It stays down as long as EVPN is configured on the same access interface. Pretty cool, right? Also note that the VPLS pseudo-wire between P1 and P3 is not impacted. It continues to switch traffic over VPLS as before. When you're ready to migrate this to EVPN, follow the same steps from 1 to 3 and you're done. Now that we got the basic concepts behind this migration, I bet you want to see this on a router. That's coming up next as part 2 of the series. I'm going to show you how there's no loss during the VPLS to EVPN data plane switch. Stay tuned.